Hello, I'm Mr. McBrien. This is TIJ1O, Mathematics and Engineering. So today I'd like to talk a little bit about the importance of mathematics. We're going to review power in a circuit for those of you who've already taken science. We'll talk about how to report calculations in TIJ. And along with that, we're going to talk about ways to increase your marks across every course that involves mathematics. So why is math so important? Well, really more than anything else, mathematics is the language that we use in science and engineering. Forget about Latin, forget about English. The commonality is mathematics. And when we do observations, we usually try to do it quantitatively. We try to do it in number form. And conversely, we consider ourselves to understand a concept if we can make predictions about what numbers will be and then confirm them with experiments. So make predictions about situations and what numbers we can expect to see and then confirm them with experiments. And when we see this, we start to talk about a concept as understood. Now, we can take a nice, easy example, and something that'll be good for us to practice in any case, power in a circuit, and we can use this without doing any complicated definitions or anything like this. We'll save that for another day. We can use this as an example to illustrate some of the techniques we want to use. So power is the energy consumed per unit time. And if we want to consider power in electrical terms, power consumed by a circuit is proportional to the current, and it's proportional to the potential, V. And so the equation looks something like this, P equals IV. We're going to use this as our target example for our talking about the process for reporting answers in our exams, assignments, quizzes, etc. And we call this process the guess process. So to help motivate you, I'm going to emphasize that the guess process is a way for you to improve the number of marks you get, especially when your answer isn't quite correct. It'll improve the chances that your answer will be right, but when your answer is wrong, it'll improve the marks that you get. So I entitled this slide, Guessing for Marks. In computer engineering, we're going to use a very simple reporting system called guess to help our thought processes, to make the marking easier on our poor old teacher, and to give ourselves increased chances for part marks when we have an incorrect answer. Now, guess is not really specific to computer engineering. This reporting system will improve your marks across your math classes, your science classes, and any additional engineering classes you take. And I have a great deal of experience marking exams at the university level as well. And I can say that if you use this approach, you will improve the marks you get when you go to university or college too. Okay, so what is guess? As you might have guessed, it's an acronym. And the G stands for givens, the U for unknowns, E for equation, the first S for substitution, the second one for solution. Okay, so let's illustrate this a bit better. What do we mean by givens? When you start solving a problem before you do anything else, start out by writing the values that you've been given. Pull them out of the word problem that you see and write them at the top of your space to put the solution. What does this accomplish? It helps you form your thoughts. You pull these values from the equation and you can see what you've got. When you put the letters in for the variables, it'll also help you identify the equation that you need in order to solve the problem. So let's illustrate this with a simple example. Let's not worry too much right now about the electricity aspect. We'll get into more of that tomorrow. But here's our word problem. What's the power consumption in a circuit that has a current of 0.003 amps at a potential of 9 volts? So again, we're supposed to put in our givens. So tomorrow we'll learn that I is the symbol for amps. For now, you can just take my word for it. I is the symbol for current. And we're given the I equals 0.03 amps. And similarly, the potential of 9 volts, V equals 9 volts. Now, we have established what we were given in our word problem. And even if all we do is that, we will get some marks on this problem. So the next letter in guess is U for unknowns. The unknowns that what the question asks us to solve. And what we need to do here is simply write a letter for the variable. The symbol for that value equals question mark. That's all we need to do. So variable equals question mark. Now, of course, you're going to put the right letter in. And if you successfully put in that correct letter for that variable, you've recorded the givens and the unknowns, and you're getting a half a mark on the question without even really knowing very much. Okay, so let's go back to our example. Our unknown, we can see the question says, what's the power consumption? So we know that our unknown is the power, and so all we write is P equals question mark. And guess what? We got a half a mark. Not too bad. Okay, next letter in guess is E for equation, and all we need to do is write down the equation that we're going to use. And this helps us identify whether the equation's in the right form, whether we need to manipulate it in some way. It helps us avoid transcription errors, and there's a full mark allocated to knowing the equation. So if you just identify the right equation, identify the givens and the unknowns, you're getting 1.5 out of typically 3 marks on a question in this class. So you get a passing mark without even getting an answer. Okay, so let's go back to our problem. Our equation that puts power in terms of current and potential is P equals IV. We write it down, and we now have achieved our first part of the question. We do need to identify if the form of the equation is correct. How do we identify that? Pretty simply. The equation should have the item we need alone on the left, and the values that we have, the givens, on the right. And if it doesn't, we have to apply algebra. Okay, so if we go back to our problem at hand then, P equals IV, the number that we need is on the left-hand side and alone, and the givens are together on the right. This equation is in the right form, and we can proceed to the next step. Okay, and the next step, S is for substitution. As long as the equation is in the right form, all we need to do is just substitute in. And if we substitute in correctly, guess what? We're getting another half mark. Okay, so pretty easy to do because we put these things right on the page, right above the equation. So all we do is write in P equals, and instead of I, we put in brackets 0.003 amps. And instead of the V in brackets, we put 9 volts. And we've successfully substituted in. Now, what's the benefit of this? Well, what this means is we can visually check to make sure we haven't made any transcription errors or anything like that in just a few seconds. There's a great benefit to us in terms of keeping track of what we're doing. Okay. Now for the calculator. And a couple of quick reminders. If you don't have a calculator, it's time to buy one. And something that many students forget to do. When you're doing your homework, get your calculator out. Don't use your phone. All right, you need to practice how you play. And of course, it goes without saying, you won't be allowed to use your phone for quizzes and tests, so bring your calculator to class. All right, so the final S in guess is solution. And so all we need to do is tap that into the calculator and get our answer, in this case 0.027 watts. Now, the one thing is though, even though we've completed guess, we're not quite done. Not if we want to maximize the number of marks we get across high school and across university or college. And I'm going to now give you a trick that can help you to dramatically improve the number of correct answers you submit for marking. Okay, and what is that trick? The trick is the two questions. Before we move on to the next problem, before we check the answers in the back of the textbook or at the end of the worksheet, before we do that, we need to ask ourselves the two questions. So the first one, what are my units? And the second one, does my answer make sense? And I want you to practice this technique when you're doing your homework. And again, it's practice how you play. Try the two questions before you look at the solutions. And I think what you'll find is a significant part of the time you'll be identifying that there's a problem and fixing it before you go to the back, and you'll be submitting better answers in your tests as well. Okay, and as a tip, you might want to try underlining the answer as you ask yourself the questions. This will remind you to do it, but it also does a favor for the marker, whoever that might be, whether it's a teacher in high school or a TA in university. It helps them by pointing them directly towards the answer that you're submitting, the thing you want them to mark. Okay, so the final step here, we ask ourselves the two questions about 0.027 watts. The first question being, are my units correct? Well, the question asked us for power, and you may know that the units for power are in fact watts. So we've got the correct units, so that's good news. We won't lose a half a mark there. And then the second question is my answer reasonable? And that's sometimes easy to answer and sometimes difficult. Now in this case, you may not have too much experience yet with power in a circuit. And that's part of why we have an assignment as part of the worksheet that you're going to see after this, at the end of this presentation. But what I can say is that 0.027 watts is a very small amount of power. It's very low power, which would be consistent with a low current and a low voltage. And we have a very low current at 0.003 amps and a voltage that's just, well, reasonable. So in this context, this seems like a reasonable answer to the question. And so on that basis, with the units correct, with the number seeming reasonable, we can underline that and submit it to the teacher for marking, or we can go ahead and flip the back of the textbook and check the answer. Okay, so let's do one more. Let's consider a problem where a Tesla car has a motor that claims 325,000 watt output. Its battery has a maximum current of 1500 amperes. If we assume 100% efficiency, what's the voltage produced by the battery? Okay, so again, we're going to look at the guess process for solving this problem. So first thing we need to do is look at the givens. And we can see here that in this case we're given a current of 1500 amperes and a power of 325,000 watts. And our unknown, well, it asks what's the voltage, what's the potential. So V equals question mark. Alright, next we need the equation. Well, we need an equation that involves P, I, and V. And of course our power equation, P equals IV. And then the question we have to ask ourselves is the equation in the right form? And so, is V on the left-hand side alone? No, it's not. Okay, so this one isn't nearly as convenient. This equation's not in the right form. So now we have to do algebra. Blast. Alright. Not very complicated though, really. So I'm going to remind you how to do this algebra. I know it's pretty basic for a number of you, but it's never a bad thing to see it again. So our equation's not in the right form. We need V on its own. We need to be able to solve for V, so we need it away from the I term. So what we need to do when we're using algebra to isolate this number, when we're isolating V, is we identify what's causing the problem. And the problem here is that V is multiplied by I, right? And we don't want it multiplied by I, we want it alone. So anytime we want to get rid of the number, then we do the opposite. So to remove it, we do the opposite. And the opposite of multiplication is division. So what do we need to do? We need to take our equation and divide the IV term by I. And that'll get rid of it. But our equation is no longer equal, right? We just divided one side of our equation by I. It's no longer equal. What we have to do, anything we do to one side, we have to do it to the other. And so we divide both sides by I. And once we do that, we get what we need. We can cancel I from the IV term, and we get our new expression. So what's this look like when we put it into our problem? What we do is we divide again both sides by I like we did in the previous graphic. And then from the right hand side we cancel I from both sides. So we scratch out the I above and below. I times V divided by I, we cancel the I terms. And then we get V equals P over I. Really, it's pretty simple. But now we have what we need. Our equation's in the right form. Our unknown is alone on the left-hand side. All right. So then we can move on to our substitution term. We can substitute in 325,000 watts for the P term and 1500 amps for the current term, for the I term. And now that's all that's left is to get out our calculator. So we get out our calculator, and what I got was 220 for the answer. So there is our solution. Are we done? No, of course not. We still have to ask ourselves the two questions. So the two questions being, first off, did we remember units? Yes, we put down volts, and volts are the units for potential, so that's good. And then the other question is the answer reasonable? Well, you may know that line voltage in North America is 120 volts. All right. You may be well traveled and know that line voltage in Europe is 220 volts. So we may not know much about a Tesla car, but we do know what kind of reasonable voltages we can expect to see in human-engineered devices. And so, to the best of our knowledge, we can say 220 volts. That sounds like something that we might see in something we might engineer. And so we can underline that as having units and being reasonable. Is it the right answer? Well, That's another question. Okay, but I do want to illustrate the value of the two questions in this case. So what I'd like to do is give us a hypothetical situation in which we made an error. Okay, so here is our substitution term where we put V equals 325,000 watts divided by 1500 amps. Now let's imagine that we messed up. Either we messed up the algebra and accidentally multiplied those two terms together, or let's imagine we hit the multiply button on our calculator instead of the divide button. If this had happened, we would have multiplied 325,000 times 1500, and we would have gotten a number for that's a lot of zeros. Okay, let's say 487,500,000 volts. Yes, I think I got that right. Now, what we can say is, whereas we could say 220 might be okay, we know that we have 9-volt batteries, we have 120-volt line voltage. This number is a lot of volts, and it'd be rather surprising if a man-made device produced those kind of voltages, that kind of potential. So, I guess my question would be this. Does that answer feel right? The more questions you do, the more you get a feel for whether it might be right. But in this case, this might be a good excuse for you to go and double check your algebra, double check with your calculator, right? Usually you have a few extra minutes in any given test. This is a perfect time to say, why don't I check that over one more time before I underline it? And with a little luck, you'll either notice an algebra error, or when you put it in the calculator the next time, it works out fine. And so this maybe, hopefully, will help motivate you to try to use the two questions more often. Okay, let's sum up. I've been talking for a while here. As we discussed, math is the language of science and engineering. If you want to be successful in these areas, you need to have a good grasp of mathematics. If you want to communicate well in these areas, you need to communicate mathematics well. We covered the concept of power, the amount of energy consumed by a circuit over per unit time, and we studied the equation of it briefly, and we applied it to investigate the guess system of reporting solutions to mathematical problems. And this system, it will help you to be more successful, to give more right answers on questions, but it'll increase the marks you get. It'll give teachers, especially me, the opportunity to give you part marks even when you don't get the right answer. And the two questions, did I remember my units and is my answer reasonable, will reduce your marks right through college or university. Okay, your homework. Please complete the Power in a Circuit worksheet that was provided. And for those of you who like, use the guess system for each question. Ask yourself the two questions each time before you check the solutions at the end of the worksheet. Okay, and have a great evening.